In Chapter 3.4, we begin to study exponential and logarithmic equations and the different approaches for solving these different types of equations. Now, we've already talked a little bit about solving exponential equations, more specifically using the one-to-one property for exponents. And we've also talked about solving logarithmic equations using the one-to-one property for logarithms, as well as rewriting those logarithmic equations in exponential form. Those were our topics that we studied earlier on in this chapter. In this section of the chapter, we are going to take a little bit more in-depth approach at the algebraic way to solve these exponential and logarithmic equations. So let's begin with solving exponential equations. Just as with solving other equations, our end goal in solving exponential equations is to find the values of the variable that make the equation true. Generally speaking, we will look to perform mathematical operations that allow us to isolate the variable. In other words, we need to solve for x. This often involves the use of various inverse operations. So, in your algebra classes, you guys have learned that the inverse operation of addition is subtraction. Why? Subtraction undoes addition. Similarly, the inverse operation of division is multiplication. The inverse operation of squaring a value is taking a square root. And in this particular case, the inverse operation of exponentiation, and we've talked about this a little bit in the beginning of the chapter, exponentiation means to put into an exponent. What's the inverse operation of exponentiation? That is going to be logging, all right? So in this case, we are going to be doing some logging to help us in solving exponential equations. So remember, exponentiation means to put something into an exponent. Logging means to take the log of something. Recognize that if your variable that you are trying to solve for is located in the exponent, you are going to have to do some logging to solve for that variable and to remove it from the exponent. All right, so as we just said, the inverse operation of exponentiation is logging. And that comes from our property that logarithmic functions and exponential functions are inverses of each other. To undo the exponentiation of a value, you log both sides of the equation. When logging, choose a base that is the same as the base of the exponent. So for example, here we have 5 to the x is equal to 27. Notice that we are trying to solve for x, and the variable x is located in the exponent, which makes this an exponential equation. The variable x is being exponentiated with a base of 5. It is being put into the exponent with a base of 5 here as the base of the exponent. To undo this operation, we need to log both sides of the equation with a base of 5. In other words, we take log base 5 of the left-hand side, and algebra says that if we do something to the left-hand side of the equation, we must also do it to the right-hand side of the equation. So log base 5 of 5 raised to the x is equal to log base 5 of 27. Why does this help us out? Well, this allows us to use the inverse property that was introduced to us earlier on in chapter 3. Log base a of a to the x power is equal to x. Anytime we log with a base that is the same as the base of an exponent located inside of the log, raised to the x power, that's going to be equal to that quantity x, right? Log base a of a raised to the blank equals blank. In this case, we have log base 5 of 5 raised to the x power. So what happens? That just turns into x. There we have x. Okay, so x is now equal to log base 5 of 27. And there we have our solution. We have solved for x. Notice that logging with a base of 5, an exponential quantity with a base of 5, undoes that exponentiation here. Those are inverse operations, and they cancel each other out. You might also recall that one of our properties of logarithms is that if we have an exponent inside of a log, we can actually bring that exponent to the front as multiplication. In other words, I could rewrite this as x times log base a of a is equal to x. And another one of these properties said that log base a of a is equal to 1. All right, and that is how we end up getting x here in this case. X times 1 equals x, another way to look at it. Okay, so a couple tips here. Complete any algebraic operations to isolate the exponential quantity first, then log both sides of the equation. The rules of algebra still apply. So this is important. Isolate the exponential quantity first. Do any other algebra that's going to get that exponential quantity on its own. Also, don't forget about the one-to-one property. A to the x power is equal to a to the y if and only if x equals y. All right, so there you have the basics for solving exponential equations. In the next few slides, you'll see a couple different examples.